All right, in this video, we are going to learn how to solve rationals without transformations. We've already learned how to graph rationals with transformations when it's in transformation form. This is the formula for transformation form of a rational. We have y equals a over b times x minus c plus d. An example of that is the problem that I have written here, where the value of a is 5, and that tells us that we're going to have a vertical stretch by a factor of 5. I can't see my b because I don't have it factored out, but if I did factor it out, let's see. I factored out that 2, I would have x minus 3/2. So if I factored out the 2, I would see my b has a value of 2. That means I'm going to have a compression by a factor of 1/2. My c, now that I've factored out that 2, my c is now 1.5 or 3 over 2. And so that means that my graph is going to be shifted horizontally to about 1.5 or to exactly 1.5 because that's what 3 over 2 is. And then I'm also going to shift it up 4. All of this is look and no information. Other than factoring out that b, I can just look at it and notice the parameter change, describe the transformations. I can also find the vertical asymptote. The vertical asymptote is going to be at positive 1.5. Did I say I shifted it to the left? I should have shifted it to the right. I think I did. So the vertical asymptote is going to be at positive 1.5. What means that's where the domain can't be. My domain is not going to be 1.5. My horizontal asymptote is going to be y equals 4. And my range is going to be every number except 4. So all of that is look and no information. Can't do that over here in this form, and it's not any different than when we did quadratics. Remember, we did 3 different forms of quadratics, and depending on what form it is, determined what we knew about the quadratic. Here we know what the y-intercept is. Here we know what the vertex is, and we can describe the transformations. Here we know what where it's crossing the x-axis. It crosses the x-axis at p and q. We know how it opens. We know its end behavior. So all of the things that, and we learned how to take it from this form and change it into this form by factoring. We learned how to take it from standard form and put it in vertex form by completing the square. So if we wanted to take it out of factored form and put it into standard form, we would multiply. So you should be able to change from each form to the other. I'm going to show you how to start with this transformation form and change it into this one. Before I do that, I'm going to go over here and show you that they really are the same graph. You'll see that here I have each one of the equations typed in a line on Desmos, and when I show you this graph, there's the red graph. I click on the next one and it turns blue because the blue is graphed right on top of the red. So the red and the blue graphs are identical. So I am going to model for you algebraically how I change this one to this one, and you should be able to follow along. I am not necessarily going to ask you in this course to do that, but if you plan on taking pre-cal or college algebra, you will likely need to be able to do that there. So I'm going to take this problem right here and I'm going to do exactly what it says to do, and I'm going to add. So I'm going to take the 5 over 2x minus 3 and I'm going to add it to 4 over 1. Why did I write it as a fraction? Because in order to add fractions, you do have to have a common denominator. So the denominator under the 5 is the 2x minus 3. The denominator over here is 1. 1 is always a present factor in the denominator because it's there even though we don't write it. We know that it's always there. So what this denominator needs is a 2x minus 3. So I'm going to multiply this side by 2x minus 3. And if I multiply the denominator by 2x minus 3, I have to multiply the numerator by 2x minus 3. So now my denominators are the same, so I'm going to add my numerators. And then my denominator is 2x minus 3. I can do more to that numerator. I keep forgetting that. I can simplify this numerator by distributing the 4. So I am going to distribute the 4, and that makes me have 5 plus 4 times 2x is 8x, and 4 times negative 3 is negative 12, and on bottom I have 2x minus 3. One more case of simplifying because I can. I'm going to put the 5 and the negative 12 together. Those are both constants, and 5 and negative 12 go together to make negative 7. And this problem matches this problem. So what we're going to be learning how to do in the next videos is we're going to learn how to look at a problem that is not in transformation form and figure out all of the parts. So we're going to start with horizontal asymptotes. We're going to learn how to find that. Then we're going to find vertical asymptotes, and I might have these out of order. We're going to find x-intercepts. We're going to find y-intercepts. And we're going to find holes, because sometimes our graph has holes. So vertical asymptotes, horizontal asymptotes, x-intercepts, y-intercepts, and holes. That's what the rest of our videos are going to be about.